Hey guys, this is the video for review 2 for this quarterly coming up. So the first question here, we have Colton is going to invest $90,000 and leave it in an account for 9 years. Assuming that the interest is compounded monthly, what interest rate to the nearest hundredth of a percent would be required in order for Colton to end up with $119,000? So things that we should keep in mind here is this compounded monthly. So that we have a formula for. So in review 1, we saw compounded continuously when it was A part. Here, our formula is A equals P 1 plus R over N raised to the NT. So A, we're trying to get to $119,000. We're starting with $90,000. We're going to have 1 plus, we don't know what R is. We know it's going to be 12 because compounded monthly, and we're raising it to 12. T, we're going to do, it says 9 years. So we're solving for R in this case. So first thing we want to do is try to isolate R the best that we can. So we're going to divide 90,000 from both sides. That ends up being 119 over 90 when we simplify it. Remember, we don't want to round too soon. So now we're looking at 1 plus R over 12 raised to the 108. So there's a couple things we could do here. We're trying to get R by itself though. So I would just say let's raise this side by this reciprocal of 1 over 108 so that it will cancel. And we'll do the same 1 over 108 here. Okay, so we're going to get that piece, and I'm going to raise that right in the calculator. And we're going to get this decimal of 1.002589. So we're going to subtract both sides by the 1. And to get R by itself, we're going to multiply both sides by 12. And I'll do that all in the calculator. So I'm going to subtract the 1 we had because I'm afraid of rounding too soon. So I just like to keep that whole decimal right in the calculator, times it by the 12. And our rate here is given, and it says to the nearest, what did we say? 100th of a percent though. So remember, thinking of the nearest 100th percent, we would times it by 100, or you move the decimal places 2 to the right, either way. But so we're looking at 3.11%. Sorry about that. 3.11% for the first one. In the second one here, it says the average profit of a local store owner earns on a given day $870. It's growing exponentially at a rate of 70% per year. So that's just talking about an annual growth. So for us, it's just the basic growth formula. When we write this here, we're looking at A equals 870, 1 plus 0.73 or 1.73 to the T. Now we want to rewrite this function in terms of monthly rate. So remember, it was T years. We want to be in months. So what I'm going to do first is just on the side, if it's in years now, we want to be in months. So we're thinking 12 months on the top over 1 year, because that's what's equivalent to each other. The reason I set this up like this is so that the years cancel, and that means my new exponent should be 12t. Now, if that's my new exponent, remember, you have to do the opposite to the rate because you want them to balance each other out. So what I'm talking about is what we had in the beginning here. We had A equals 870, 1.73. Now I just told you that 12t is going on the outside here. On the inside, we're raising it to 1 over 12. And we're going to round to the nearest 4 decimal places. So this doesn't affect the 870 at all, remember. We're just raising that inside piece. So 1.73 raised to the 1 divided by 12. 4 decimal places, we're looking at 0.0467. And that would be in months. Okay. For 3, we're told that t is in years. Rewrite the function so it's a yearly rate. So it's just the opposite here. T by itself would be years, right? So we have right here 12t. So this is not in years right now. We're trying to get t by itself. So to get t by itself, the only thing I'm going to do differently is I'm going to take the function we have, but instead, since I want my exponent to just be t, I'm just going to slide that 12 right in. So, and in order to do that here, rewrite the function in terms of yearly rate. I could plug it in. It didn't tell me anything that I would have to round to, unfortunately. So in this case, even if I did that by 1.085 to the 12th, we'd be looking at this number inside there. But if you left it just alone as is, this is technically in years. So I'm just sliding it. Because remember, we wanted t by itself. We had 12t. That's the difference of why I'm sliding it in versus doing the reciprocal like I did on the last one. Okay. In number 4 here, we have in a lab experiment, the decay of a radioactive isotope is being observed. On the first day of the experiment, the mass of the substance was 1,100 grams, and it's decreasing by 15% per day. Write a recursive formula to represent the mass of the radioactive sample on the nth day. Anytime you see recursive, remember we should talk about A1 or something on the first day. So on the first day, 1,100. So automatically, because remember, you'd always need something to plug in. So I already have that. At least there's my partial credit here. So it's decreasing by 1.5% in this part. So I want us to think about if I were to write out a formula. So I'm going to put this on the bottom for a second. If I were to have this, I would be looking at something along the lines of this. So we know that we would have had my 1,100, which we already covered. 1 subtract 0.15 to the t. That would have been my formula. Since I'm writing it recursively, what I'm going to do to switch this up, though, is I'm just going to take this piece, but we're doing it on the nth day. So instead of t, I'm going to have n. So a of n is equal to 1 subtract the 0.15 is the same as 0.85 to the n. So these two things together make up that recursive sequence right there. So you're taking that, we have the first term and we have the other piece. It's just saying in terms of n instead of t. Okay. A small country emits 82,000 kilotons of carbon dioxide per year. In a recent global agreement, a country agreed to cut its carbon emissions by 3.5% per year for the next 6 years. In the first year of the agreement, the country will keep its emissions at 82,000 kilotons, and the emissions will decrease each successive year. How many total kilotons of carbon dioxide would the country emit over the course of the 6-year period? Keywords, things that we want to look out for, are something like total. So we're trying to figure out all 6 years, not just a one-time deal. So let's just think about what this would look like first. If it was just a regular decay, which is what we're trying to do, it would look like A equals 82,000. We would have 1 subtract 0.035 per year. Now, we don't want to know just what the 6th year is. We want the total. So this is going to involve our old sequences. But when we see total, we're looking at the formula S of n equals A1 minus A1 times R to the n all over 1 minus R. So in this case, when we go to set this up, A1 is this first term here. So that's what I'm putting in for these A1s. So I'm looking at 82,000, subtract 82,000. R is our rate. So that's everything here. So that 1 minus 0.035. Okay, and that's just the same. And then the time, we're doing it a total of 6 years. And then on the bottom, 1 minus that same rate of 0.965. And at this point, I'm going to let the calculator do all the work for me here. So remember, I would do my alpha y equals 82,000 minus 82,000, 0.965 raised to the 6th, 1 minus 0.965, and that would be the total. Now let's talk about why this makes sense as well. The first year was 82,000. Even though the next year is going to be less because it's decreasing, it's still added to that 82,000. Same for the third year. It's going to be a little bit less, but it's added to those 2 years prior. This is the course of 6 years altogether added up. So it's still going to be more than 82,000 because that's just the year one. But it's decreasing a little bit each year, but then you're adding up the total emissions for those 6 years. So each of those 6 years are still being added together. Okay, let's look at number 6 here. So we're talking about recursive sequences again. So we want to find the first 4 terms, but we already have A1. A1's done. We have it right there. A2, remember how we get this though. I'm going to change up my colors just for a second. A2 is equal to plugging something in plus 2x minus 5. Because I'm plugging A of n minus 1 always refers to the term before it. So this was, if I want A2, the term before 2 is 1. So I'm going to plug that in here. And when I add that up together here, we're going to take 4x plus 2x and get 6x. 3 plus a negative 5 is a negative 2. We do the same thing. A of 3 equals something plus 2x minus 5, because that A of n minus 1 is changing every time to plug in the previous term. Now, if I want 3, the term before 3 is 2. So I'm plugging in that answer instead. And when I do that here, I'm going to have 6x plus 2x is 8x. Negative 2 minus 5, negative 7. and that's a of 3. And lastly, we'll do it for that fourth term because we want